Elimination of arbitrary constant. We have two rules in eliminating the arbitrary constant. First, the number of differentiating the given equation is the same as the number of arbitrary constant to be eliminated. In simple words, kung gaano kadami yung arbitrary constant natin, yun din yung bilang ng differentiation na mangyayari. Second rule, the desired equation is free from arbitrary constant. So yung final answer natin, dapat wala ng arbitrary constant na makikita or dapat eliminated na lahat ng constant. To further understand this topic, here are some examples of elimination of arbitrary constant. So in this first sample or example, we have ax squared plus bx plus c is equals to 0. The first step we need to do is to identify how many arbitrary constant are there in this given function. We have a, b, and c. Therefore, we need to derive this function 3 times. So, the first derivative of this given function, which is the derivative of ax cubed, we have 2ax plus the derivative of bx, which is b, plus the derivative of c constant, which is equals to 0. So our y prime here is 2ax plus b. For the second derivative of this given function, we have the derivative of 2ax, which is equals to 2a, plus the derivative of b constant, which is equals to 0. Lastly, so our second derivative here is 2a. Lastly, for the triple prime or the third derivative of this given function, which is the derivative of 2a, we will getting 0. So the differential equation that we obtain in the given function ax squared plus bx plus c is equals to 0 is y triple prime equals to 0. This is our final answer. In our second example, we have x cubed minus 3x squared y equals to c. So in this case, we have only one arbitrary constant, which is c. Therefore, we need to derive this given function once. So the first derivative of this given function is the derivative of x cubed is 3x squared minus the derivative of 3x squared y is 3 times, copy the first variable and then get the derivative of y, which is, it will become y prime, plus copy the second variable and get the derivative of this first variable, which is x squared, and it will become 2x equals to 0. To simplify this function, we need to multiply negative 3x to x squared y prime plus y 2x. Rewriting this function, we have 3x squared minus negative 3 times x squared y prime. We will get negative 3x y prime, and negative 3x multiplied by 2xy, we will get negative 6x equals to 0. In this whole function, we have similar terms with which is 3x, so we need to divide it by 3x. So 3x divided by 3x squared, we will get x, and 3x divided by 3x squared y prime, we will get xy prime, and 3x divided by negative 6xy, we will get 2y is equals to 0. And take note that this y prime is equals to dy over dx, therefore we need to multiply it by dx to simplify this whole function. Multiplying dx by this whole function, we will get dx multiplied by x, we will get x dx minus dx multiplied by x dy over dx, and the dx will be cancelled out here and here, and we will get x dy, and 2y multiplied by dx, we will get 2y dx is equals to 0. And then combining similar terms, we will get x dx minus 2y dx minus x dy equal to 0. And we have also to factor this out because they have a similar term. So our final answer here is x minus 2y dx minus x dy equals to 0. This is our final answer. Our last example, we have y is equals to c1 plus c2 a raised to 3x. So in this situation, we have two arbitrary constants, which is c1 and then c2. It means that we need to derive this formula twice. So the first derivative of this given function is the derivative of c1 is equals to 0, and the derivative of c2 e raised to 3x is equals to 3c2 e raised to 3x. Therefore, our y prime here is c2 e raised to 3x. For the second derivative of this given function, we have 3 multiplied by 3, and we will get 9. So our y second prime here is 9c2 e raised to 3x. Take note that our goal here is to eliminate all arbitrary constant. So in this situation, we have not eliminated the arbitrary constant c2. This constant, we need to use two equations. So for our first equation, we have y prime is equals to 3c2 e raised to 3x, and for our equation 2, we have y prime is equals to 9c2 e raised to 3x. From equation 1 and equation 2, we have the solution. Adding the two equations, we have y prime is equals to 3c2 e raised to 3x plus y prime is equals to 9c2 e raised to 3x. The next step we do is to think of a number that we can multiply by 3 and added by 9, and we will get an answer of 0. In this case, we multiply negative 3 by this whole function. So negative 3 multiplied by y prime, the answer is negative 3y prime, and negative 3 multiplied by 3c2 e raised to 3x, we will get negative 9c2 e raised to 3x. Adding the two equations, we have this solution, or we have this final answer, which is negative 3y prime plus y second prime is equals to 0.